Afternoon to all, and welcome back to the channel. Today we will be continuing on a video that I've posted a couple of weeks ago for the learners that I do teach, the video on congruency, but the video that I posted was on the cases of congruency, and it explains the 4 different conditions that you would get for congruency. So I'll post that link in the description if you would like to just catch up on that and then follow through with this video. Today in the video we will continue to do different cases of congruencies with regards to examples and how you should answer these questions when they ask you different types of questions regarding congruency of triangles. So now first question that we've got here, we've got a rectangle, but they're obviously going to put in one of their diagonals. Okay, so we've got a rectangle. Just see what's going on here. So, rectangle, here we go. And then they put in this diagonal over here, running all over, and then we'll call this P, S, and then we'll do Q over here, and then R at the bottom. Then these 2 indications are put in here, and then over here we've got an indication, and there as well, and then we've got a 2, and a 1, and a 2, and a 1 over there. Okay, now with regards to conditions of congruency, you must also note that you need to work with the statement reason columns, like we've done with the previous geometry of straight lines as well as the other 2D shapes. With this, you need, for each statement that you make, you need a reason, because you get marked on the following, if I can put it this way. So with any congruency case, there must be 3 reasons or statements. Then you need to provide the condition that you are working under, as well as the conclusion to state. Due to these 3 facts and this condition provided, I can therefore say that triangle so-and-so is congruent to triangle so-and-so. Okay, so with regards to this question, I'm going to have a few questions that we are going to work on. Okay, so the first question that we are going to ask is to prove. So the first one, question A, we're going to prove that triangle PQS is congruent to triangle RSQ. Okay, prove that triangle PQS is congruent to triangle RSQ. Now, one thing that you need to understand is the fact that the diagonal that runs through from the bottom left to the top right corner is a common side, okay, which is the hypotenuse of both these triangles if it is proven that they are right angles. Okay, so to prove the congruency, you now need to go and find the condition that you want to work with. Okay, now remember, it's not shown here that these 2 triangles are right angle triangles. So the other condition that I can work with, because I already have 2 corresponding, or rather 1 pair of corresponding sides and 1 pair of corresponding angles, and because this is a common side which is shared by both triangles, so it should be equal to one another, I can work with, instead of the RHS method, I can work with the SAS condition, which is side, angle, side, which is over there. So, statement reason, I'm just going to put an S and an R. Obviously, in your papers, you write out statement reason. So, to prove the congruency of this triangle, the first thing that I would work with is the following. I will work with side PS and side QR. Now, these indications here show that they are equal to one another. So, side PS is equal to side QR. Okay, and your reason there is simple. It is given to you. It's given to you. How was it given to you? By these indications that were there. Okay. Then the other thing that you can be sure of is obviously the angles that were given to you. So angle S2 is equal to angle Q2. And how is that they are equal? It's also given to you because they indicated to you that they are equal by putting these dots there. Then, as I've said, this diagonal over here is shared by both the triangles, which means it should be the same length. So both the triangles' sides there should be the same. So what you then say is side QS is equal to side SQ, or you could say QS, it's up to you. And the reason for that is because it's a common side. Common side. And why do I say it's a common side? It's because it's shared by both the triangles. Both the triangles make use of that side. Okay. Then, once you are done with that, on the reason side, you need to give me the condition, and you will see that I've written all of these in the condition format. So SAS, that was the condition that I worked with, which is side angle side, which is the way it was written here. Then, with my three facts and my condition, I can therefore make a conclusion. That's why I say therefore. So therefore, triangle PQS is congruent to triangle RSQ. And there you go. All sorted, out of the way. Now, another question that I'm going to quickly just touch on is they can ask you that. They can ask you now, prove that angle P is equal to angle R. So prove that angle P is equal to angle R. Now, obviously, in the previous question, you've proven congruency, okay? Which means that these two triangles are exactly the same triangles, okay? With regards to the lengths in the corresponding sides, as well as the angles in the corresponding angles, okay? So, to prove that angle P is equal to angle R would now be an easy task. So all that you can do is you can just say that angle P is therefore equal to angle R. And your reason there is simple. You've proven congruency in the previous question already. So therefore my reason would then be these two angles are exactly the same size due to the fact that triangle PQS was congruent or is congruent to triangle RSQ. And because the two triangles are congruent, therefore then the two angles will be exactly equal to one another or the same in this regard. Okay. Okay, let's move on to another question quickly. If you look at the following question over here, let's just see. Yeah, let's work with this one. So I've got two triangles here. So here's the first one. Oh, triangles are not coming out as expected. Yeah, luckily I'm a math teacher, not an artist. There we go. Then this triangle we'll call A, B, and C. And this triangle over here would then be D, E, F. And then we'll have indications over here, over there, here's a dot, there's a dot, and then we've got the two indications over there. Okay, obviously first question would then be the following. I would ask you the following question, so I'm just going to write them here. So the first question I'm going to ask you is obviously to tell me or to prove the congruency. Prove that triangle, let me just close it, triangle ABC is congruent to triangle DEF. Okay, now if you look at this, you'll see that you've got one pair of corresponding angles over here, one pair of corresponding angles at the top, and then you've got one pair of corresponding sides. So now you need to go look at which condition you are going to work with. So the condition that allows you to work with two angles and one pair of corresponding sides is the SAA method. Okay, so first of all, statement, reason, and to prove the congruency, okay, I need to start the same way that the condition allows me to, with the sides. SAA, so it's going to be side, angle, angle. So our first side that we're going to look at would be BC, which is equal to EF. And the reason there would be, obviously, it's given. It's given to you. Okay? Then angle B is equal to angle E. And the reason there would also be given. Then for angle C would be equal to angle F. And that would also be given because they gave it to you. Then the condition that you worked with was SAA. So SAA. Therefore, triangle ABC is congruent to triangle DEF. And there you go. There you've proven the congruency with regards to the triangle. Okay, now I'm going to ask you another question. So, question B. And this question says, state two reasons. So state two reasons which can be used to prove that angle A is equal to angle D. So, give me two reasons to prove that angle A is equal to angle D. So, for the first one, it's easy. Okay? The first one is very easy. So, remember, this is question A, then we'll do question B over here. The first one is easy. The first reason you've done in the previous question. You've already proved it. So, because the triangles are congruent, then obviously angle A and angle D would be equal to one another. So, angle A is equal to angle D. And your first reason out of the two is the fact that triangle ABC is congruent to triangle DEF. If these two triangles were not congruent, there would be no way that these two angles are equal to one another. Okay? Then, another reason, you need to go and look further into the property number 1 of straight line, or not straight line, 2D shape geometry. You've got two angles here that were given to you. Okay? Two angles that were given. Which means you only need two angles to be able to calculate one of the other missing angles, the interior angles. Because all these angles are equal to 180. So you'll basically say angle F plus angle E plus angle D equals 180, and then we calculate for D or for A in this regard. So the other way, or the other reason to say that angle D is equal to angle A is simply through sum of the interior angles of a triangle. So there's your two reasons. It's either it's congruent, or it could be calculated with the sum of the interior angles of a triangle in this regard. Okay. Okay, now carrying on to our next question, and this will be the final question for this video. And the question looks as follows. So we'll have A, B, C, and D. Then I'll have 1 and 2. I'll have markings there and markings there. And then I'll have 2 and a 1 and a right angle over here. Okay. With this question, I'm going to do 3 different types of questions. Okay. Obviously, one of them will be to prove that it's congruent. Okay. But we will look at a couple of questions to make sure that you will be able to handle anything that comes your way, that your teacher throws your way. Okay, so the first one, so I'm going to write the first question here. The first one states, what is the, oh my goodness, look at that H. What is the size of angle B2? What is the size of angle B2? And then I'm going to ask you to give me a reason. Give a reason. Then, question B, I'm going to ask you, prove that triangle ABD is congruent to triangle CBD. But here's the catch. I'm going to ask you to prove it in 2 ways, 2 different ways. Prove it in 2 different ways. So there are the 2 questions that I'm going to ask you. Okay, so first question asks us that statement reason always asks you, what is the size of angle B2? Give a reason. Okay, now straight line geometry comes into play over here. Straight line geometry comes into play. Please don't think that you've gotten rid of straight line geometry because you are now busy with geometry of 2D shapes. Your straight line geometry is the only way that you can prove that B2 is what B2 is equal to. Okay, now obviously you all know it's 90 degrees, but you can't just say, oh, it's 90 degrees and then you don't know how you got there. Okay, it's going to leave you with a bit of a problem with regards to your marks and all of that for that question. So for question A, they ask you what is the size of angle B2? So simply as follows. So for question A, angle B2 is equal to 90 degrees. And the reason why B2 is 90 degrees is the fact that they are adjacent supplementary angles. So adjacent supplementary angles. And the reason why they're adjacent supplementary angles is because you've got your common arm that comes through here. It shares the vertex at B. And obviously, because all of them share the same vertex, these 2 angles should be adjacent to one another. Okay, and that's how you calculate question A. Moving on to question B. For question B, they ask you to prove that triangle ABD is congruent to triangle CBD. Okay, in 2 different ways. So I'm going to show you the first method. Obviously, we've proven now that both these triangles have a 90-degree angle, which means out of the 4 conditions, the first condition that you can use, and the first one that all of you would obviously run to, is the RHS method, which is right angle, hypotenuse, and any one of the other available sides that you can use. Okay, so first of all, right angle. Yes, B1 is equal to angle B2 because they are both 90 degrees. And how do you know that they're both 90 degrees? Because you proved it. It was proven. Now you're going to ask me, how did I prove it? You proved it in the first question by saying that they are adjacent supplementary angles. Okay, then we move on to the hypotenuse. Hypotenuse was given to you. So AB, or rather AD and CD are equal. AD is equal to CD, and that was given to you by these indications or these markings there, so given. And the only other side that you can use in the RHS method is side BD, because it's a common side. Remember in the previous question we also had a common side that we used. Now obviously this side for both triangles would be exactly the same length. So angle, or rather side BD, is equal to side DB, and the reason for that is because it's a common side. And that's the only reason why they are equal to one another. Then, obviously you've got your three facts. So now you need to give me the condition that you work with, which is RHS. And therefore, triangle ABD is congruent to triangle CBD over here. That is the one way or method that you could use to prove congruency. Now, the other method that you could use to prove congruency is as follows. Let me just put statement reason down again. So, if you look at this triangle, or both these triangles, there are certain things that you need to pick up. So, they've given me one pair of corresponding sides, okay? And then they've given me one pair of corresponding angles, which I proved in the first question. So I proved that this side is 90 degrees, which is equal to B1, okay? Then, there's another thing that you need to look at. You'll see that these markings are given to you here, which means that this is an isosceles triangle. Remember, the properties of an isosceles triangle is that it's got one pair of adjacent sides that are equal to one another, and as soon as these sides are equal to one another, then the opposite base angles should be equal to one another. Okay, so let's start with that congruency now. First things first, you need to go and look at your condition now. So you've got one pair of sides, one pair of angles, and then the other thing that you had to check is that because these sides are equal in length, then obviously it means that the two base angles should be equal in size, because it's an isosceles triangle. So I'm going to use the SAA method, okay? SAA method. So we're going to start with the side. So side AD is equal to side CD, and that is given to you, okay? Then you're going to tell me that angle B1 is equal to angle B2, which is equal to 90 degrees. And that was proven in question 1. You proved that in question 1 already with the adjacent supplementary angles. Then, because these two sides are equal in length, the base angle should be equal in size. So therefore, angle A is equal to angle C. And the reason for that is because these two angles are angles of opposite equal sides. Because the sides are exactly the same length, the two base angles should be exactly the same size. Now, if they gave you the two base angles and I asked you to prove that the sides are equal, then angles and sides would swap around in the reason. So it would be sides of opposite equal angles. Okay, so it's a bit confusing in the beginning, but if you get it, then it will all go well. So if you're proving the angles, then you say, and they give you the sizes of the sides, you'll say it's angles of opposite equal sides, because the sides are equal. But if they give you the angles and they ask you to prove that the sides are exactly the same length, then it will be sides of opposite equal angles, because they've given you the sizes of the angles. Okay, so carrying on the question, they've given you already, or rather you've done your three facts. So the method that was used was the SAA method, side angle, angle. Then therefore, triangle ABD is congruent to triangle CBD. And that is it. You've answered both the questions that they asked you to answer. Okay guys, this is it for the congruency video for today. As we continue with regards to congruency, and as it gets more difficult, we will obviously make more videos. There will be another video posted tomorrow on congruency, and the congruency for tomorrow will obviously be a bit more, how can I say, difficult than today. The level of the questions will be a bit higher. But thank you once again for tuning in. Please ask your friends to join the channel and get everybody involved to ensure that they understand and make sure that they have resources available to them with regards to their studies and so on. Until we meet again next time, bye bye.